Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to another video, especially for my grade 11 advanced students. Based on your request for your coming exam for Math EOT Term 3 exam coverage, I'm again here with you for learning objective 19 on binomial theorem. This video is going to be very helpful if you want to understand how to solve the FRQ question where you use the binomial theorem to write and find the coefficients of specified terms or indicated terms in the binomial expansion. I would advise you to watch the video till the end because in the end I will give you the answer key so that you can check your answers. And if you find this video helpful, please like, share and subscribe to the channel and let me know in the comment section which video you want next on my channel. Okay, so let's move on to learning objective 19, which is based on binomial theorem. This key concept that you see written here is binomial theorem, and for solving the question for learning objective 19, you need this important formula. Okay, so binomial theorem can be written with NCK a to the power n minus k, b to the power k. So this is summation. Summation means sigma notation 0 to n. This is the formula for binomial theorem, but just to solve the question which is there in your EOT, you only need this part. So let's see how we use this. In the question, the first term a will be given to you, the second term b will be given to you, and the power n will be given to you. You just need to find the indicated term, and k would always be whichever term is asked. For example, if it asks the fourth term, then you take 4 minus 1. That will be your k. Okay, so whichever term is asked in the question, subtract 1, that's your value of k. You need 4 variables. You need the first term, you need the second term, you need the power n in the question, and you need k. Once you know all of these 4, just apply this formula to get your answer. Means use nck, a to the power n minus k, b to the power k, multiply all of this, the first term, the second term, the third term, and you will get your answer. Also remember, the formula for nck combination is n factorial over k factorial multiplied with n minus k factorial. Definitely you can use your calculator for shortcuts, but this combination formula you need to remember. Put the correct values, and let's now see how we solve the question. Okay, so let's apply the formula for solving these questions. So the formula I will be using is nck a to the power n minus k, b to the power k. So let's see what is our a, b, n and k. So a is x, b is 2z, so the first and the second term, n is the power 7, and k I told you is 1 less than the term that you have to find. So here you need to find the third term, so k will be 2. Let's put everything here and apply the combination formula. And remember, we need to multiply all 3 of these. So this multiplied with this, multiplied with this. Let's calculate them one by one. NCK. First calculate this. So 7C2. How do I calculate? Formula is 7 factorial over 2 factorial over 7 minus 2, which is 5 factorial. Now how do we open this? Always open the numerator big factorial till you get the next factorial. So 7 multiply with 6 till I get 5 factorial, because in the next step I will cancel the 5 factorial. So let's cancel this. This is gone. What is left? 7 multiplied by 6. 2 factorial is 2 with 1. So this gives me 21 as the value of 7C2. Now let's calculate a to the power n minus k. So this is x to the power n minus k means 7 minus 2, 5. And b to the power k is the second term, 2z to the power 2. So this is going to be 4z squared. Now just multiply all these 3 together. So I multiply 21 with x to the power 5 and this. So the final answer, that is the third term, would be 21 multiplied with x to the power 5 multiplied with 4 z to the power 2. So what is this? 21 multiplied with 4, combine the numbers, it will be 84, and x to the power 5 z to the power 2. This is the final answer. Let's do one more. Here we need to find the fourth term. So k will be 4 minus 1, which is 3. The first term here is y. The second term here is 3x, but this time it has a negative sign, so it's better to write the question again in this form so that you know that the second term is negative. This is a good way of writing. So the power is 6. Now we are ready to solve the question using the same formula, nck a to the power n minus k b to the power k. So let's calculate nck. Nck will be 6c3. A to the power n minus k will be y to the power 6 minus 3. B to the power k will be second term, which is negative, to the power k, which is 3. So let's find one by one. So 6 factorial over 3 factorial, 3 factorial. So open the 6 factorial, 6, 5, 4. Denominator is 3 with 2. Cancel 6 with this, so 5 4s are 20. The value of 6c3 comes out to be 20. This is y to the power 3, very easy, and this will be minus 3 to the power 3 x to the power 3, so this is negative. It will come out to be negative 27x3. Now we just need to multiply all of them together. Nck with a to the power n minus k, b to the power k. So I multiply 20 with y to the power 3 and this. So use your calculator and get your final answer. Multiply 20 with y cube with minus 27x cube. All of this is multiplied, so make sure you put the brackets and don't make a sign mistake. So this will come out to be negative 540 x to the power 3 y to the power 3 as the final answer. That completes learning objective 19. Just to give you a little bit more practice, let's do 2 more questions. Again, same method. So here we need to find the 7th term. So k will be 7 minus 1, which is 6. The first term is given to be 2a. The second term is given to be negative 2b. So it's good to write the question in this form first and then proceed. So let's find nck. N is 8, k is 6. So this will be 8 factorial over 6 factorial, and 8 minus 6 is 2 factorial. So we will open 8 factorial till we get 6 factorial. So 8, 7, 6. Always remember, we open the numerator till we get the next denominator so that we can cancel and simplify. 2 factorial is 2. Numerator is 8 with 7. Cancel it. So 7 with 4, this is 28. Nck comes out to be 28. Now next is the next term, which is a to the power n minus k. So a is 2a, the term, and the power is n minus k, means 8 minus 6. So I will just change it. So this is the term first, and we have to do n minus k, so 8 minus 6. So this will come out to be 2a to the power 2. If I simplify, 2 to the power 2 is 4a square. Let's go to the second term. Second term is negative, and for the second term we are doing the power as k. So minus 2 b to the power k is 6, so negative 2 to the power 6 b to the power 6. So let's see, use your calculator, what this comes out to be. It's coming out to be 64b6. Now multiply everything together. So we multiply 4a square, we multiply 64b6 and 28. So the final answer, which is nck a to the power n minus k b to the power k. So 28 multiply with 4a square multiply with 64b6. It will be a big number. Make sure you don't do calculation mistake. Multiply correctly and this will come out to be 7168. This is a big number. Then a square b6. That's the final answer. One last question. A here is 4x, the first term. B here is 5y, second term. Power is 6, and k will be 1 less than the 6th term. So 6 minus 1, 5. Okay, so I'm directly now putting the values because we've practiced a lot of questions. So let's just multiply directly. So NCK means 6, 5, first term to the power n minus k means 6 minus 5, 1. Second term to the power k means 5. Okay, so this is going to be 6 factorial over 5 factorial, 1 factorial. This is very simple. Here it will become 5 to the power 5, y to the power 5. So I'll open the factorial on the top 6 till I get 5, and therefore 5 factorial is going to cancel. And then we just multiply 4 with 5 to the power 5. X has power 1, y has power 5. So the final answer after the multiplication will come out to be 6 multiplied by 4 multiplied by 5 to the power 5, x, y, 5. So this is going to be a big number. Multiply correctly and this will come out to be 75,000 XYQ. Okay, now let me provide you the answer key for all the questions so that you can check your answers for this learning objective. Okay, so for this learning objective 19, where we use the binomial theorem to expand power of binomials, for question 23 to 28, this is the answer key for learning objective 19.